Hello everyone. In this session, we are going to discuss about the layers. In the previous session, we talked about the neurons. What are the neurons and what is the neuron architecture? Now we are going to discuss about the next level, that is called the layer. So, this is the first part of the unit officially, and it is the practical approach for how to design the layers and all. Let us start with that. So, layer is the fundamental data structure for the neural network. It is a collection of neurons. If you have the three neurons, actually in the previous topic we discussed about a single neuron. So, if you collect number of neurons and make them into a single layer, then it is called the layer data structure, fundamental data structure for the neural network. If you collect the number of layers stacked into a network in the order, then it is called the network, neural network. So because of that reason, it is a fundamental data structure. And what the layer will do is, it will do the data processing module. It is the data processing module, and it takes the data, that is the tensor as the input, and the output will be again the tensor. So the tensor will take and tensor will be given as the output. So what is the tensor size and what is the tensor? Tensor means it is the vector. Okay, so the vector can be represented in different by using different libraries, by using the NumPy object or by using the tensor, and there are so many other objects also available to represent the vectors. So one of the vector representation is the tensor. So by using the TensorFlow library, we can represent this. So the layers, the layer is having the data processing by using the tensors. Now it is having the inputs, and also it is having the outputs, and also it is having some more data, that is called the weights. Weights means in the previous session we discussed that there is the theta concept. The theta, that is the parameter. So there are number of parameters available. How many number of inputs are there? Those many number of parameters will be generated, and they have to be maintained. They are also called the weights. So that is also a tensor. So they are called the learning parameters. They are called learning parameters. Why? Because they will be modified while training. If you increase the number of iterations, if you perform one iteration, the value of the weights will be modified. And different types of layers are available, like a simple dense layer, and it may be the CNN, convolutional neural network, or it may be the recurrent neural network. Like this, there are several kinds of layers available. Based on that, we can call them, we can categorize them by using the tensor rank, meaning that rank 2 tensor means it will accept only 2 dimension. Rank 2 means 2 dimension. It will accept 2 dimension, that is the samples and features. Samples means you need not think much. Samples means number of records or number of rows. And features means number of columns. We will call them as the attributes. We can call them as the attributes or columns. So they are called the features. Samples means number of records or number of rows. So the tabular data, generally for the tabular data and also for image data also we can use the rank 2 tensors, that is enough. And rank 3 tensors, they are having 3 dimensions. Another dimension is, that is the timestamp. Same as the sample and features, there will be the same, but one more extra parameter is the timestamp or timestamps. We can call them as the timestamp. So these are the various 3 parameters, that is called the rank 3 parameter. And rank 2 parameter, they are the dense layers, and rank 3 parameters, they are the recurrent layers, and they will be used in the LSTM, RNN, LSTM, GRU, like this, the series handling, series analysis. For the series analysis algorithms, we will use the rank 3 tensors. Now let us build the library, that is the layer. How can we build the library, layer? By using some libraries. Actually, we have to start from the scratch. It is a long processing. It will take the long time to implement from the scratch. So instead of that, we can use the existing libraries. There are so many libraries available which provides the algorithms. So one of the library is the TensorFlow. As I mentioned that in the previous slide. The tensor handles the vectors as well as it is having the predefined models for the deep learning. So we are having the predefined models in the TensorFlow, and of course some more abstract level of the algorithms that is also available. That is by using the Keras. Keras is another library. Before TensorFlow 2.x, that is in the 1.x, the Keras was the separate library. We have to integrate them while developing the application. But from the TensorFlow 2.x onwards, the Keras was integrated in the TensorFlow so that we can call that as the module of the TensorFlow. Keras has become as the module for the TensorFlow. And now the layer. Now what we are discussing is the layer. The layer what is the layer? The layer is an object in the Keras that encapsulates some state that is called the weights and also some computation, that is the forward pass. What it has to compute, that will be handled by this. So you can say that here the layer object consists of several things. One is the attribute and the methods. Attributes are the weights here, and the method is the forward pass, that is the call. So how can we design these weights? How can we process that? That is for the forward pass. That is by using the build method. By using the build method, we can generate the weights. We can create the weights by using build method. And if you want to modify those methods, or if you want use those weights. So if you want to use the weights or if you want to modify the weights, we have to use some other methods. That is called the fundamental method is the call method. The call method, it will use the weights and it will go forward. For the forward pass, we will use the call method. And for updation of the weights, we will use some other method that we will discuss later. So this is the basic implementation of the TensorFlow layer, that is the layer. How can we implement? Actually, there are two ways to implement the layers. One is by using the application, that is the API, by using the API, or by deriving the new class from the existing class in the available package or available library. So here in the Keras, as I mentioned you, the Keras has become as the part of the TensorFlow. So from TensorFlow, we are importing the Keras. And from the Keras, in the Keras, there are so many components are there. One of the modules is the layers. All the standard layers, they are available in the layers submodule. And inside that, there is a basic layer class available. So we are deriving the new class, that is the simple dense, from this keras.layers.layer. And then we can, this is called the overriding in your Java or in any of your object-oriented programming. We are using this concept, that is the overriding. We are overriding the simple dense from the keras.layers.layer. So in this, there are several methods available. So one of the methods is the init method. The init method, it will initialize the object. It will initialize the simple dense object. So here we are just defining the class. We are not creating the object. Okay. So for that we have to define what is the init method, how it should be initiated. That has to be provided. That is by using the init method __init__ of self, and you have to initialize the layer with the number of units. How many number of units? In the previous case, you have seen that only single bubble. For the single bubble, number of inputs I have given and one output has given by the neuron. But here, how many number of such neurons have to be there in the single layer? That you have to provide it. That is called the number of units. Number of neurons, that is the number of bubbles, that is called the number of units. And activation, what type of activation you want to provide? That we have seen that in the previous session, we have the sigmoid function, sigmoid activation, ReLU activation, and also the softmax activation. These are the various activations available. So one of the activation, we have to go with some of the, we can go one of the activation, we can use some of the activation. So here, that you have to mention. And here we are calling the actually units is the attribute defined in the superclass. So I want to use that parameter self dot units equal to unit, and super dot unit we are calling the unit method from the superclass, that is the layers, and then for this class we are initiating the number of units with the units provided by this, and activation also we are initiating with the provided activation. And build method, the next one is the build method. It will be used for creation of the weights. We will create the weights by using the build methods. And how can we create the weights? How many weights are required? That is the number of inputs given. That is called the number of weights. How many inputs are there? Those many weights are required. For example, if you have the 5 inputs, 5 weights are required. Let us say, for example, if you are giving, I will give you one more example, our regular example. We are taking the number of hours of study, number of hours of sleep. We are taking these two as the parameters. For these two parameters, we need two parameters. For these two inputs, we should have two parameters. That is W1 and W2. So, how many number of weights required for two inputs? Two. Two weights are required. Now, for one neuron you need two weights. For the second neuron, number of units we are providing, number of bubbles are there. For the first bubble, two inputs, two weights. For the second bubble, two inputs, two weights. Third bubble, two inputs, two weights. Meaning that how many number of units are there multiplied by number of weights required for each unit. So that is called the number of units into number of inputs. That is the columns, the number of columns. You have to forget about the number of samples or number of records at this moment. How many number of columns are there? Those many number of weights are required. Those many number of inputs are there. So those many number of weights are required. So here with the same scenario we are doing that self dot W equal to and we are initializing the dimension, input dimension. What is the input dimension? Let us say, for example, if I give the number of studies of hours, number of hours of sleep, if you take these two, then if you have the 100 student information, what will be the size, what will be the shape of the data set? That will become as the 100 by 2. 100 by 2. Now, how many inputs are there? 2. Within the tuple, we want to take the second part, meaning that last part of the tuple. That is, how can we get that input shape? Input shape will be, in my example, whatever I have given this example, in this, the input shape is, total input shape is 100 by 2. Now I want to take only 2, that is the last parameter. How can we get the last element from the tuple? That is input shape of -1, reverse indexing. By using the reverse indexing, we are taking that. After that, by using that, the 2 into how many input dimensions and number of units. How many number of units? Those many weights are required. So for that, we are taking self.w equal to self.add weight of shape equal to, we are creating the shape, that is input dimension and the number of units. With this shape, we are creating the weight vector and we are initializing with the random values, random number. And for each unit, how many units are there? Those many number of bias will be there. Bias means intercept. In your machine learning, you are calling that as the intercept. Here we are calling that as the bias. The bias will be, how many number of bias will be there? Depending upon the number of units. Number of units, in our example, number of units are 2. Studies, number of units. Number of units, how many units we are taking? If we are taking 5 units, 2 inputs and 5 units. So see here, self.units, how many number of units you have provided? With that we have to create the number of biases. So and then initializer is 0. We are initializing that with 0.